Welcome to Bite-Size Data Science. In this video, we discuss data understanding and data preparation. I've talked about data understanding or exploration in 3 previous videos. In video 17, I showed how we can explore data using Spark data frames. In video 18, I did the same thing, but this time I used Pandas data frame. Finally, in video 32, I used data coming from a relational database. This time I don't spend much time in the data exploration part, so please review the other videos for details. Instead, I explored the data to see how I can better organize it for modeling. I am using the IBM Watson Studio environment to run my notebook. If you are interested, you can find a link in the description on how to create a free account on that platform. Links to the notebook I'm using here are also available in the description. I'm using the Chicago accident data I used in the data exploration videos. What we see from the original data is that we have multiple character fields. Most of those fields include categorical values. Let's see how many distinct values we have in each column. I am using the DB2 database as my relational database system engine. If you want to use another engine, the code presented here should be easy to adapt. We have 47 columns since I got rid of the location column. This is not a problem because I still have the longitude and latitude columns. Instead of writing the SQL statement manually, I execute a simple query to get all the column names and then programmatically create the SQL statement by looping over the column names. We see here in the output the count of non-null values and the count of unique values for each column. This confirms that many character columns are in fact categorical with few unique values. In the next step, we are doing what's called in the relational database world normalization. This serves multiple purposes. For example, when we have a character field that is up to 80 characters long, like in the case of prime contributory cause, we can replace it with a 4-byte integer that references the 38-row table containing the unique values for that field. We have 157,852 non-null values for that column in that field. Assuming that the primary contributing factor string averages a length of 40 bytes, we go from using 6.3 megabytes to using around 583 kilobytes, or around 10 times less space. We have 16 columns we can convert that way with varied level of space savings. The second benefit is that now we have numerical values instead of strings, which fits better many modeling algorithms. To do the conversion, we need to create additional tables and populate them with the appropriate values. Again, instead of coding the table definitions manually, I use Python to generate my code. I loop over the column names I am interested in and pass the names of the columns to a generic statement. Then I use the same approach to populate the tables. With this, I created and populated 16 tables in no time at all. Some modeling works better with less choices in a categorical field. For this reason, we have to look at the distribution of our categorical attributes. By the way, there are additional fields that were originally numerical that are also categorical. We're using the fields we previously identified and added 7 more. We use Python to help create the SQL statements to find out the count of each different values for each attribute. We end up with 318 records. Then we use matplotlib to graph all the categorical columns. We see, for example, that traffic_control_device has 15 possible values. We could probably cut it down to 3 values, 12, 13, and others. The same could be done for device_condition. Weather condition should probably even be reduced to 2 groups. All other attributes should be reviewed the same way. I want to point out a few others. We should probably ignore work_zone_type from any modeling since it is mostly one value. Then, despite having 31 different speed limits, we should probably have 2 choices. It is either 30 miles per hour or not. The same could apply to injury_total. We either have injuries or not. There is a lot more exploration that can be done to better understand the data. We'll continue our exploration and preparation in the next video. See you next time on Bite-Sized Data Science, and don't forget to subscribe.